So next we're going to look at running Probit and Logit models in R. So I'm going to pull in the same data set. I'm going to run two calls. I'm going to call the library foreign to open data files in R, and I'm also going to call the library arm, which allows me to calculate the inverse logit. I'm going to load my data, and what I would do next, if I hadn't already done it in data, is to run some basic descriptive statistics of our variables of interest. So we're going to look at the exact same model. Our dependent variable, again, is conflict recurrence within 1 calendar year. Our main independent variables are truth, government victory, life expectancy. So the code you can use is GLM, and then you specify the link. So in this case, we're going to look at a logit function. So when we run this and produce the results, you can see that we have very similar outcomes to what we got when we ran this model in data. So truth increases the log odds of conflict recurrence within 1 year, holding government victory and life expectancy constant. Government victory is now reported a result, and it has a negative effect on conflict recurrence, holding truth and life expectancy constant. And then life expectancy decreases the probability log odds of conflict recurrence in 1 calendar year, holding truth and government victory constant. And also, what we notice is that running this in R using this particular call, it was able to produce a result for government victory. But what we notice is that the standard errors are huge, and we don't have any statistical significance. And so this is telling us that it's having a very hard time estimating the coefficient for government victory. And this makes sense because Stata actually reported that it failed to do so. So if we look, you can see that there are 18 Fisher scoring iterations. So there are some problems the model is having in estimating this, and so we should take that into account in terms of interpreting our results. So next we're going to obtain the confidence intervals around our coefficients, and we can do this by running confident and then whatever we defined the object for our model. So here we see our 95% confidence interval, right? Again, so government victory is not statistically significant at conventional levels. Confidence interval is huge. Both truth and life expectancy have a statistically significant effect on conflict recurrence. So next I'm going to save my coefficients as an object, and you can call it. This will be useful in a moment. So what we can do, similar to data, we can compute the odds ratios by exponentiating the coefficients. So we can do this for particular variables, or we can do this for the entire model. So, and if we call this, it's reporting the odds ratios now. Once again, these values are very similar to the values that Stata reported. Again, the odds ratio is around 7.8 for truce. It is estimating government victory. Close to 1. It's 1.57. So what you would do is you would say that government victory increases the odds by about 57%. So 1 is always our base category. And then we have life expectancy, and this is a very, very small but negative value. So again, we can call a particular coefficient, so we can calculate the odds ratio for just truce. This is a theme. And then we can calculate our confidence intervals. So this is showing us our odds ratios and our 95% confidence interval. Next, to calculate the probabilities, we use this code. And we can set particular values. So for example, if we would like to look at the predicted probability of conflict recurrence in a case where there's a truce, there is not a government victory, and life expectancy is set to the mean, so about 55. The predicted probability of conflict recurrence in this case is about 54%. So next, I'm going to show you how to run the Probit model. So all that is different between this line of code and the line of code that specified model 1 is that we've changed this from Logit to Probit. So again, truce has a positive effect on the probability of conflict recurrence, holding government victory and life expectancy constant. Life expectancy again has a negative effect, holding truce and government victory constant, and R is again able to compute government victory. The standard errors are also very large, so it's having trouble, because as we saw before, there's actually perfect prediction, there's perfect separation based on government victory on our dependent variable. So next, similarly, we can obtain the confidence intervals for our coefficients. And so here it's not even computing the confidence interval for government victory, since it would be so large. So here we can see with our 95% confidence level, truce and life expectancy are both statistically significant. And so another way to calculate predicted probabilities is to run this predict and then specify our model, which in this case is model 2, and we can specify the type, which in this case is response. And then we can just summarize this. So the predicted probability in this case is telling us that the mean predicted probability of conflict recurrence is about 20%. It reports all these summary statistics, right? So the min and max. So again, the probability of conflict recurrence, when we're looking at these values, seems to be around 20%. Unless we specify specific values such as truce. When truce is equal to 1, this And all of the estimates has greatly increased the probability of conflict recurrence to around 50% in many of these models. So it seems like when you compare the baseline of about 20-some% to around 50%, that truces significantly increase the probability of conflict recurrence within one calendar year. So this is how to run Logit and Probit models in both R and in Stata, and how to produce predicted probabilities.